Hey everybody, Mr. Stewart here, and welcome back to Math We've Got This. In this video, one of two short videos, we'll see how we can use Desmos to graph a nonlinear relation and examine it as well. So in our investigation, you were tasked with finding pairs of numbers that produced a product of 36. So if the first number is x and the second is y, here are many different pairs of values that give us a product, that is when we multiply, of positive 36. So just several ordered pairs that give you a product of 36. Something else you noticed that was in quadrant 1 as well as quadrant 3. We also noticed that as we read the graph from left to right, we have a clear decreasing pattern here. In fact, a beautiful curve, smooth curve that goes through these ordered pairs. And same thing here, starting up here, that is sort of in that positive infinity. As y tends towards positive infinity, as we move in the positive x direction, we can see our y values are decreasing, or that rate of change is decreasing. As we move in that positive x direction towards positive infinity. So there's a nice throwback to our discussion around infinity and limits. So something else that you did was, after having observed that particular pattern, you came up with a relation, in fact, an equation. So this one here, x multiplied by y, or xy, equals the constant 36. So I'm just going to erase the ink markings here just to make that much more visible. So you can see here a smooth, beautifully smooth curve that goes through all of those pairs, ordered pairs, and it's defined by the equation x, y equals 36. Now, something else that we did was to look at, not just the graph in its entirety, but also to examine some of those points so we could better understand the relationship between x and y and certain characteristics of the graph and of the relation. So when you plot the line y equals x, okay, where every x coordinate equals its y coordinate, if we go over to the graph, you're going to see that it intersects at 6, 6, so specifically where x does equal y, and also here in quadrant 3 at -6, -6, which just so happens to be the square root of positive 36. So there's something to remember as a characteristic when you are graphing these types of relations. Something else to take note of is also that this line, y equals x, okay, this highlighted line, acts as a line of reflection. So for instance, if I were to take this point here, 18, 2, and compare it to this here, 2, 18, you'll notice that the x and y coordinates have completely shifted roles. Same thing here. Let's go to quadrant 3. Let's examine these 2 points. So here's -12, -3, but then over here, we've got -3, -12. So again, you can see that that line, y equals x, is used to reflect different parts of the graph, that is to map it onto itself, and all of the points, all the x's and y's happen to change roles. Okay, so let's remove that line. Another line you plotted was y equals -x. So it's the same line, except it's pointing in a different direction. So it has a negative rate of change, or a negative slope. So with this line of reflection, and what's really interesting about that is if you look at any of these ordered pairs, so let's take this one, 2, 18 again, and we'll contrast that against -2, -18. What you're going to notice is that, let me highlight those again, is that the x and y values have not only flipped or changed roles, they've actually changed in their sign. And just to add a little more proof to that, let's take 6 and 6. And again, oops, sorry, wrong one. Well, let's keep that highlighted for a moment. There's -6, -6. And I'll grab this point here, 9 and 4. So again, you can see how the x and y coordinates have